Hello Year 14. This week's review we're going to look at recursion, just a quick review of recursion, look at the homework answer and then also the revision question on floating point, simply because I forgot to record it. So if we look at let's begin with just looking at a recursive function that we studied in class. Understand what makes it recursive. It's in line 13 where it makes a function call to itself, and then it should have something called a base case. So your homework answer is, what is a recursive, or if your standard exam answer, what is a recursive function? A function that makes a call to itself until a base case is met. And the binary search, as you see on the screen, is a popular implementation of a recursive algorithm. Homework questions. So I've sort of tweaked an answer here. Look again, iteration. We have learned that whatever can be implemented recursively can also be implemented iteratively, and you should be able to explain why you would go for a recursive implementation or why an iterative. And you know what iteration is. This idea that we've got a loop and we've got two types of loop. We've got count controlled for loops and condition controlled while loops. So some type of simple answer, and it would help if you referred to it. The idea of it's a loop until either for a set number of times or until a condition, and there is an example there. You only needed 2 mark points. So if you said it could be count controlled, it could be condition controlled, or even referred to an example, that would be fine. Recursion, and this idea, we want a function call. Function that makes the calls to itself until base case. So really the 2 mark points for that question were quite clear. It was base case and it calls itself. So any sensible answer that included that. Now on to the higher level answer where we're looking at, well, why would you go for iterative, or why would you go for a function? What are the advantages of iterative compared to recursive? And it comes down to efficiency and memory. When you call a recursive function, it makes copies onto a memory stack of all the local variables. So if you think of a binary search of 16 elements, there's going to be 4 recursive calls. That is going to require 4 blocks of memory in the stack. Whereas iterative, we're just going to have constant use of the memory in an iterative binary search. So if you talked about that idea that the use of memory is more efficient, and then it's fair to say that more often, not all the time, that an iterative function will be faster, will be more efficient. And especially as the problem set grows, you know, if you're going to have a recursive function that's going to call so many times, you can have you'll have a recursion limit. So if you mentioned in the second part that more often than not it is more efficient, and it will grow, or it will work on extremely large problem sets. Right, that was your homework, and what I wanted to look at was a review of just a question we did in class, because you know this is going to come up on your March assessment. And where are we? We are with data representation. Bear with me. Yep. This was the question in class. Look, we went through it, and again we'll just look at the basics. When you're presented with this question, make sure you read it carefully to find out that it's in 2's complement, and it asks somewhere in, did it say normalized form? We've got the number and it should be normalized form. So the first step, stage 1, is convert 5.75 into binary, and we're going to have, well, we've got 5101. And we know that the decimal for 75 is 0.11, a half and a quarter. But we're not in 2's complement form. We need a positive number. So there's the first stage. Next is floating the point. It asks us to be normalized. And remember that a normalized positive integer will begin with 0. So I'm floating the point 1, 2, 3 places. So I've got an exponent of the value of 3, but it needs to be in 2's complement. Finally, it said I've got 10 bits and I've got 6 bits. So I need to add well, first of all, I'll start with exponent. Let's add another 3 zeros without changing the value of that. And then I've got 1, 2, 3, 4, 5, 6. I need to add in another 4 zeros to the mantissa without affecting the value. 1, 2, 3, 4, and we end up with our answer. So that's floating point. Pause the video, rewind it, whatever you have to do till you get your head around that. You will be faced with a similar type question in the March assessment. Have a good weekend, folks, and again we meet on Monday. Slan slan.